This is a talk on Postgres, JSON, and you. My name is Dave Stokes. Oops, hold on, I gotta get to the. I'm a community manager at dbeaver, which is an interesting database tool if you haven't used it. If you work with a lot of databases or you're importing and exporting a lot of data, check it out. There's an open core community edition that's real fun. I've been in open source for a long, long, long time. I actually started my professional career before there was such a thing as open source. So this has all been halcyon days. If you uh, are fairly new to the computing world, it used to be you bought one machine from one vendor and paid out the nose for it, and nothing uh, interoperated with anything else. And over the past 30, 40 years, it's been a marvelous development. Um, my experience with databases goes back a long time. I used to work for MySQL AB. I've recently worked for Pacona. I got into working with JSON and databases back in MySQL 8 when they released the JSON data type. I was so appalled at the documentation that I actually got frustrated and wrote a book on MySQL and JSON with the Oracle Press. Unfortunately for me, the Oracle Press disappeared, and I ended up doing a revision and self-publishing that on Amazon. So if you're in the MySQL world also, you might want to look at those. So I'm going to do this presentation backwards. I tend to do a lot of things backwards, unfortunately. That's just the way of my life. Um, JSON and JSONB, we'll talk about that in a little bit, is ideal for semi-structured dynamic data. Um, and you should probably avoid using them if your data is very highly structured. You need strict integrity, is queried frequently, and you need performance. Um, I'm talking about using normalized tables and generalized columns. If you're in an environment where you're on day one, day two, and you're not quite sure what your data structure looks like, everything's in flux. There is nothing that so, stays longer than a note on a post-it pad. JSON and JSONB are kind of an interesting way of storing your data. You don't need to be as rigorous about what you're doing. So in that case, it's a good choice. But most of the time, you don't want to do that. If you really want performance, you don't want JSON. So I'm going to go through all the things that are bad about using JSON and JSONB. And I'm going to ask you as you go along to evaluate your cases carefully. So now that I've given you that warning, um, it, it, they're both great, but double check your assumptions because it may not be the best choice for you. So why would you not want to use these two data types? First is query performance. If you really need that last percentage of performance, the standard relational model where you're doing joins between tables works best. It is the way to do it. Third normalized form or better. I can't do the math, but I've had it done for me before that shows how much it works better. If you don't believe me, there's some documentation on the net about this. Other thing is if you really do need a lot of searching on your data, um, JSON's probably not performant way to do it. You got GIN and B-tree indexes on columns, but they're going to pale in comparison using B-tree on just a standard column. Also, write performance. If you're writing a lot of data, JSON is binary format, and the indexing can slow down inserts and updates. Comparison to a standard relational column, it's night and day. You really want to avoid it if you're really looking for write performance. Data integrity. When you're dropping stuff in JSON, there's really nothing out there unless you're playing with the JSON schema.org recommendations to enforce that your data is complete. Do you have missing key values in data? Are they the right data type? If they put down a phone number, they typed in true, that's valid in JSON. How are you doing things like email? Or is that tag or key going to be email, camel case mail, dash mail, electronic mail? There's really no way to enforce that unless you do a lot of tricks, and it's not built in by default. So if that's the type of thing you need, you're not going to get it right here. Referential integrity. If you know how to use foreign keys, uh, it's probably a big boon to you, but JSON doesn't have that. Validation overhead. If you're going to go out and make sure your data is good before you write it to the memory or the disk drive, you're going to have to do a lot of complex stuff to make sure that data is good. It's not built into JSON atomically. So, uh, other things is storage inefficiency. The JSON data type stores data as a text. It's not going to collapse white space. It's not very space efficient. JSON-B stores things in a binary format that's more efficient, but it's not that more efficient. If you're storing something like an age, someone's age, doing that in a JSON thing is going to take up more room and effort to do than just an integer column. Also, large documents. Large JSON documents can have a lot of bloat, and reading them in and writing them out is not the best way to do things if you're really trying to go after that last couple percentage of performance. Complexity. If you're used to doing a regular select column A from table A where X equals Y, the query complexity with JSON just looks absolutely horrendous. You're using all these funny arrow operators or octothorpe arrow operators, having to navigate the JSON path. The queries look absolutely horrendous if you're coming from a standard SQL standard background before JSON. Also, the various arrow operators and all that don't always go between the various databases. So the octothorpe arrow that you see there is not going to work with MySQL. Joins involving JSON-B are less intuitive and may require some very messy query design to get them to do right. So once again, I'm giving you the reasons not to do that, and we'll go into why you want to do that. Limited type safety. The JSON or JSON-B fields store text as things as text or binary. So sometimes you enter some nasty casting for specific operations. This can cause all sorts of inconsistencies and also puts a lot of rigor on you to make sure you get it done right. Also, in comparison to the native column types like varchar, int, numeric, and all that, that's all built in. If you try to put a string into an integer, you're going to get at least a stern warning depending on how you have things set. So if you're depending on that, you're not in luck with JSON or JSON-B. When your data is highly structured, every record looks the same. There's no variation. You have 10 million customers and every row looks like the next row. That's going to be great for speed and indexing and data integrity. But JSON-B is kind of designed for like your clothing manufacturer. And item 1 is a t-shirt, and you have color, size, material. The next record might be a pair of pants where it's going to have, length, size for length, or waist size, leg size. The structure between the data items is going to be variable, and that has its own problems. But this is a way to do it with JSON. Backup and migration challenges. Doing migrations between one to the other, so like you're going from MySQL to Postgres or back and forth, it gets a little fussy trying to move JSON data back and forth. You end up doing a lot of dumping to the least common denominator and pulling stuff back. Also, backups of large JSON-B columns can be slow because in comparison to the standard columns, it just takes up more size. Also, debugging and maintenance. JSON-B is less transparent than the standard relational data. So if you're just looking at it with your eyeball, it sometimes gets really nasty, and you end up using something like a JSON pretty function to read the data, especially when you have people who nest arrays within arrays and all that. It comes up on your screen and it's just a big text blob. Now, JSON is supposed to be easily human readable, but a lot of developers tend to take it to the opposite extreme where you look at one record and you have arrays embedded up with all sorts of stuff. And if it pops up on your screen, so like in VI or something like that, just looks like a core dump. Also, developers unfamiliar with JSON operators, they're used to using standard comparators, greater than or less than or equal. They see a dash, right arrow, and if they're not used to it, it's kind of hard for them to adjust. Oops. If you're using ORMs, an object relational mapper, which I highly recommend, they tend to have limited support for the JSON types, making things a little more frustrating for you when you're um, architecting your data. And also, a lot of the reporting tools need extra help getting stuff out of JSON, and it may not uh, be to your best interest to have to fool with that. Also, a lot of times you see JSON as a catch-all. You'll see a table that has some sort of index for an ID field. That's the primary key, and then the next thing is a big JSON blob. It's not efficient, and it comes a lot of messy side issues, such as giving you a lot of technical debt when you're in the future. Now, sometimes, like I said earlier, day one, day two on a company and everything's in flux, it helps. As you start trying to grow and you have to get more than a dozen records at a time out of the system, it gets messy. Also, once again, make sure your developers just aren't using it as a bucket that they shove everything into. If they really need the columns for performance, break everything out in its own column. Okay, what are some alternatives if this morning's kind of scared you a little bit? Once again, normalize tables. Um, if you if you're good with normalizing your data, this is the way to go. Use separate tables, break down to third or fifth normal form. Well, I should say third or better. Like this example here where we have address where it's broken down street and city, and JSON-B have separate columns for that. Take your JSON information and use it as a generated column. And that is a good way to make sure that you have a column that the system can use easily. Those columns are usually very simple to index and are very fast. Key value tables. If you have some very simple data, this is a way to go. Sometimes we overthink things. And if you're using things like a cache, similar to like Redis or Valkey, sometimes that's a better way to go. Now, if you have, by separate columns, I mean, if your JSON fields are consistently present, store them as their normal native column types. If all the data you need is there, it's easier just to transition them out of JSON into a native column. And sometimes you need a dedicated NoSQL database. Now, if you truly are taking advantage of the document database world, especially deeply nested JSON, maybe you don't want to use Postgres. You want to use something like Mongo. So I've seen all those caveats. How do you actually use JSON and JSON-B with Postgres? Well, the question here becomes to be or not to be. Please forgive that bad joke. Postgres has two types of JSON data storage. You might remember 15 years ago, we were told the document databases were going to be the end of the SQL databases. So it became SQL or NoSQL. And ironically, the relational world said, hey, we can just add that as a data type, and did so. In typical Postgres overdue, they ended up with two data types. And by the way, before the JSON data types in the old days, if you were playing with something that's in JSON format, or you're running a really old version of Postgres, and shame on you for doing that, the JSON information was just shoved into a text column. So what are the differences between JSON and JSON-B? Well, in storage formats, JSON is just a text column. It preserves the order of the white space, and more importantly, it preserves the order of the keys. We'll talk a little bit more about that a little bit. The JSON-B is a binary format, which kind of sorts the keys, and it's optimized for querying and indexes. Now, performance-wise, JSON-B is going to be faster, and you can index it. It's probably what 99% of you should probably be using. Indexing, once again, that's JSON-B's charter there. Now for space efficiency, JSON by itself, you're storing extra white space and sometimes extra formatting. If a key is repeated 10 times, you're saving that key value 10 times. JSON-B doesn't store multiple keys, but it is a better choice there. Key order preservation, we'll talk a little bit more about that, but if you have, it keeps the item potency, and once again, I'll get into that more. JSON-B does not preserve key order. It kind of alphabetizes everything out you as it goes out of the store there. The JSON-B, what you put in there is what you get out. So if you have duplicate key values, they're going to be in there. JSON-B is only going to keep the last value. So if you have X equal to 1, X equal to 2, X equal to 3, and put it in that order in a record, you're only going to get to keep the last one. Use case, suitable for data that is rarely queried or modified, or an exact preservation input is needed. Let's say like you have some fancy Internet of Things sensor and you need to capture things as it arrives from that IoT device, throw it into JSON. If you're looking for a little bit more optimization on storage and ability to search it, throw it into JSON-B. So 99 times out of 100, you're probably going to want to use JSON-B over JSON. It's a better choice for performance, indexing, support, and storage. Once again, use JSON only for cases where you really need to preserve what exactly came in. Now, once again, this is for semi-structured data that doesn't fit well into a relational schema. Things change per record, but it's still the same data item. Now, once again, if you can get away from using JSON, JSON-B, you're going to get better performance and you'll probably be happier with your data. So you're going to have to use JSON-B, and to do that, you get indexing, which gives you better performance at looking up stuff. If you're you can use a gin index to optimize queries on keys, values, or nested structures. That's probably the way to go. Try it out with a B tree. Sometimes the data actually runs a little bit better on a B tree for if you're doing expressions on the data. Avoid over-indexing. Once again, the more indexes you have, the more maintenance you have, the more space they take in memory and disk. Gin indexes are usually much bigger than B tree and take a lot more maintenance to keep them up to date from the system's part. By the way, on that, make sure you're vacuuming your tables with JSON or JSON-B columns on a regular basis. Don't rely on auto vacuum to do everything for you. Also, validate your JSON input before inserting it. As I mentioned, the JSONschema.org folks have some good ideas there. There's some extensions that work with that. It's a lot easier to keep the bad data out and not write it to disk than having to go back in, hunt it down, correct it, and then rewrite it. Do as much as you can on the application level to make sure your data is good before you try to write it out to the database. Or do some stuff with check constraints to enforce the rules. Heck, you should probably do both. Like I mentioned before, once the data is in there or wrong your database, it's much harder and more expensive time, energy, and sanity to correct it. Query efficiency, use the JSON operators that the good folks on the core contributors have given us for precise access. The more you do stuff with JSON for complex queries, the more the optimizer has to double check stuff. Normalized tables are a lot easier that way. Now, you can combine JSON queries with relational tables or relational columns. You'll see an example of that. to get the strength of both. Try to keep your JSON data lean. Avoid storing excessively large JSON documents. Once again, they take up space, and that space is not only on your network and disk drive and memory, but it just is not going to be helpful if you really need performance. And once again, if you're always pulling out the standard things, name, address, phone number, email, extract them with a generated column, or do that at the application layer and write them into a standard column before you put it out there. And one of my pet peeves is overly embedding um, into the JSON, where you have like a restaurant and then you have 25 reviews, all as separate things in an array under that restaurant. That gets hard to read and hard to parse. Monitor your database. Make sure you're using explain to double check that everything's going well. Maybe the performance is slow when you decide to use a generated column to pull something out, a key value out of the JSON field into your regular table, and then use that in your query. And once again, make sure you regularly vacuum and also run analyze on your JSON-B equipped tables. Now, as I mentioned earlier, if you're in the early days of some sort of project, JSON-B is great where the schema is rapidly evolving. It's very expensive, especially if you have a lot of replication going on in a cluster, to make DDL changes and flush them out over all the servers and all that. In that case, JSON-B is a wonderful tool, but make sure that you're doing that just because things are changing and not out of sloth. By the way, when you do make changes in your JSON-B columns, like I mentioned earlier, the email or the uppercase M mail type changes, make sure you note that down somewhere, because things get confusing later and you need to go back and double check what was changed when. Now, once again, there's no referential integrity. If the relationships between the various tables are really critical, you probably want to stick away from using stuff straight in JSON. Pull it out. Also, you're going to have to learn how to use the various JSON path tools for complex queries. They're really messy logically, but they work well. It's one of those things where the old C days where you had a pointer of arrays to pointers, logic kind of iterates back here, but you will need to learn the path expressions to be able to dig down into that JSON document. Now, here are some examples. I don't think you can see my mouse here. Hopefully you can. Here we're going to have a table users, ID, serial key, serial primary key. We're going to have a name that's text, and we're going to have a column named preferences that's JSON-B. Similar table, ID, serial primary, and a log entry that's JSON. So whatever we put in this is going to be stored exactly as it is. JSON-B, whatever we put in is going to be, I wouldn't say optimized, but it's going to be, well, it's kind of it is an optimization. So we go to insert data. Here we're going to insert into users, name values, first value for the name, you see in single quotes. And then we have this JSON document here. Whoops. And you have to pay attention, single quote, double quote, things within brackets. If you're not used to notation, this is a key, this is a value, another key, another value. Settings is a key, and in there we have consider it an array, a font size, and a value. Now our JSON data, not the JSON-B, this is going to be recorded as you see here, event, timestamp, details, user one IP address. Now, when we're retrieving data, you're going to end up using either the single arrow operator or the double-headed arrow operator the octothorpe double-headed operator or others. In this example, if we're going to go out and get the theme, we're going to say where preferences theme, we're going to pull that back by itself, and we're going to double check that email notifications are turned on. Also, we can go out and use the octothorpe double thing to go out and pull just the font size from the settings. Now, from the JSON table, we can say, okay, we can find anyone that has theme where the theme equals dark. Do that search for us, kind of like a text search. Now, updates are fairly simple. You use update the table, set with what you're changing. Notice this is a key value. Also, you can set preferences equals to the function JSON B set preferences, and you're going to go out to languages and set that to English. Now, indexing, once again, JSON B only. To create a GIN index is very simple. Create index, the index name that you want, the table, and you have to specify you're using GIN preferences. Now, if you only want to index the theme, here's the way you do that. You say, okay, go out and find all the keys that are preference and find the ones that equal theme. Okay, complex documents. JSON path is going to be your tool to go out and find complex structures. In this example, we're going to go out and find anything in the preferences key that has a settings array. And from that settings array, we're looking for the key of font size. For those of you who are used to the standard select A, B, C from whatever table, this takes a little bit of getting used to. But as you need to dig down into the documents, this is what you're going to use. Now you can mix JSON and traditional data types. Once again, if you stick to the traditional data types, you'll have better speed. But in the real world, you're going to find yourself doing things like this, where we have a table called orders with a primary key called ID, a user ID that is a key into the users table, and then the order details JSON B. Yes, I know this is sloppy, but that's the way it is in this example. So into orders, we're putting in this JSON document, and to get that information, we're going to select stuff from this order table, where we're going to look at the order details, and we're going to be looking for something that has items greater than 0 and the product ID, and we're going to pull that as product ID, and that's how you can combine the two. It's a little messy, but it does work. Once again, keep your data clean. Forgive me for harping on this, but when I talk to young DBAs or what they used to call DBAs and young developers, I need to really stress this over and over again. Use constraints. Check to make sure that there's a theme in the preferences, and that the theme is either light or dark. You don't want them putting in true or a phone number or an email in there. Make sure the data is as good as you can get it before you go to write it out. Okay, if you want to extract all the unique themes from the preferences, this is a way to ask for distinct preferences from that user table. And here's an example where we're going to count orders by product ID. We're going to select the JSON array elements function to go out to the order details and pull out the items and get the product ID from that. And we're also going to get a count. Okay, additional notes. Once again, compared to a standard relational column, a JSON-B column is going to be slower to peek through to get your information. So normalize your data, extract stuff from JSON if you can, if you really need performance. If performance doesn't really matter, you can stick everything in JSON-B. Also, check the features of your Postgres. JSON table just came out this year, which is a wonderful way to keep your document data, your JSON data in JSON format, but temporarily converted over to a structured table for processing with standard SQL commands like winnowing functions. If you're running Postgres 14, you don't have that. If you're running 17, you have it. Also, something I highly recommend is learn to use JSON Be Pretty. Here's our data. I do select data from JSON ugly. I love that table name. And here's our information. Now imagine there's 25 more columns and it all wraps around your screen and you're up late at night and you're trying to find out why something's not working the way you want. It's easier to plug the output. All I did is put JSON pretty here, and it comes out and it pretty prints it for you. Very, very handy. Okay, generated columns. I mentioned this several times. Generated columns basically came out in Postgres 12, and a value is either computed from other columns, most of the time, like you're adding a sales tax, or you're pulling that data from another field. And let's do an example. Generated columns defined using the generated always clause. You extract specific fields from the JSON information by using like the arrow, double arrow operator. The value is computed and stored. The virtual stuff is coming, virtual generated column. And once you have that column that extracted the key value data, you can do whatever you want to, like index it and use all sorts of constraints. It's very, very handy if you're always using those fields for computations or searching. Once again, if you have something that you're always using, like you're always looking up a phone number or you're looking up a zip code, it's easier to pull that out of a standard column than out of the JSON. Now, if you want to pull stuff out as a text value for string-based queries and indexing, the double arrow operator is going to be the way to go. You might have your own preferences there. And you're going to use the singular headed operator to try to keep the type, but this is less common for generated columns. Adding indexes, once again, B-tree gen or whatever other column type you want, really helps optimize queries. Double check running explain on this. Now, you could go out and index everything in that JSON-B column, which is going to be ungodly slow and really messy, and it's hard for the system to keep the maintenance up on that. Pull out the data into its own column, index that. Also, try to keep your data types consistent. If you're pulling out a true or false, try to keep that as a Boolean. If you're pulling out an age, integer names are going to be text. If you start mixing and matching, your results can be indeterminate. Once again, use explicit casting and generate expressions. It gives the system as much help as you can to keep your data happy. Once again, avoid using generated columns. If you're bringing in 5 columns and everything gets generated 3 different ways, that's really going to slow down your system. If you're not looking at that column on a regular basis, so like you're keeping track of autos and inventory, you might be looking at the VIN number, the vehicle identification number, on a regular basis. Seat upholstery color, probably not that often unless you're in an upholstery shop. Okay, combine everything with constraints. Put constraints on your generated columns. Make sure that you're getting what you want. Use not null to keep things nice and clean. Also, watch your storage impact. Generated columns are stored in disks. They increase the table size. It could be a trade-off. If you're extracting something like a 256 character field, you really only need 2 or 3 characters of that. It's not a good trade-off. I'll once again use PG column size to take a look at how much this affects your storage. Once again, if a JSON B column is always present and has a fixed structure, really consider normalizing as a regular column instead of keeping it as JSON. There's no rule that says you have to keep the JSON data if it comes in as JSON, unless you're using the JSON data type instead of JSON B. Okay, once again, use explain or explain analyze to make sure that things are running as good as you can get them. If you do a direct comparison with pulling out a JSON B with a generated column, 99.95% of the time it's going to be faster with the generated column, but double check, you might be an edge case. So here's an example. We're creating a table. We have the preferences column that's JSON B, and we're creating a column named theme that's of type text. And what we're doing is we're going into that preferences JSON B column and pulling out the theme and putting it in there. So as soon as this data hits the server, it knows it wants to extract that one item and put it out there. Here we're putting in some data. Values, we have a name of Alice and theme dark, email notifications true, font size 14. Second record is Bob, theme light, email notifications false, font size 16. These columns are automatically populated on the preferences JSON B column. And if we go out and select preferences, you see that we have the theme dark, email notifications true, font size 14, and the same for the Bob record. Now, if we want to go out and search this information, we're going to select name, theme, email notification from users where theme equals dark. Remember back here, theme is just these items here. That is going to be a fairly quick query. Now, we could also combine JSON B queries where we're going to say, okay, we want basically name, theme, and this time we want to pull out the font size from the preferences column. Now, here we have an example where querying on email notifications are faster and simpler than the double arrow operator theme. Once again, go out and run, explain on these test things and prove it to yourself. It's easy to add a generated column to an existing table, alter table, add column. Here we're adding one called font size. It's going to be integer, generated always, and stored on disk. And we're telling it to get that information from preferences. We're going to go up to the font size, and we're going to make sure that it gets put in there as an integer. If we are not 100% sure that everything is a integer out there, do the casting. Here we can create an index on theme. Really simple, like you're used to doing on other indexes, because it is a regular standard column. Now, you can also do a unique index on a generated column within the index, where we're saying, okay, we're creating this unique index on the users table, and what we want to do is we want to extract the email from the preferences column. Here's an example of adding a constraint check. We're going to check that the font size is between 8 and 24. You try to put in something that's 7 or less or 25 or greater, it's going to kick out that record. Once again, harping on this, keep the bad stuff out. It's easier than having to fix it later. Now, we can update, here we're going to update a JSON B column. and the generated columns update automatically. So if for Alice, we're adding a font size and it's out there. Okay, nested JSON. This can be a problem because a lot of document database gurus tend to really overload things. And in this example, we're going to have a column named product ID, type of integer, generated always and stored. What we want is the order details where the items is greater than 0. We want to pull out the items at 0. We're going to extract out the product ID. So we pull in the items, the product ID is 101, the quantity is 2. We select that information, it pulls it out for us. We don't have to search through the order details. We have the product ID already extracted. Performance. Generate columns typically uses a simple query plan and usually can hit the index directly 9 times out of 10. And once again, go out and take these two queries and do explain analyze, where we're playing with the extracted generated column versus digging through the JSON. Especially as your data grows in size, this is going to be a lot faster than this. Now, what are the things to be worried about with generated columns? You can't directly go out and play with that column because it's something that's calculated. You have to change the source of where that data comes from in the generated column. If you change that generated column, I don't think you actually do that, but the idea is that since it's calculated from a value of something else, you have to change that something else to get the generated column change. Once again, virtual generated columns are coming, hopefully in this year. So a stored generated column does take up extra space, and there's a little bit of extra cycles used to actually extract whatever you're doing or whatever function you're making to get that data before you can store it. And also, if you're doing something really complex, in there, the generate column may really slow down things. You might want to look at a way to do something at the application layer or another level to take care of that. So when do you not use generated columns? Well, if your JSON-B structure is changing on a really frequent basis, they may not work for you. For one-off queries, directly go out to JSON-B and grab that data. If you're going out and doing frequent queries like this one, data double arrow email, data double arrow status equals active. You're going to be able to run exploit on this and see that select email from user where status equals active is going to run. This is going to run a lot faster than the top query. So if you must use JSON, JSON-B, consider these strategies to avoid drawbacks. Generated columns, index smartly, make sure you validate your data, normalize when possible, and go out and monitor your data. Use something that actively goes out and checks your system to see how things like hit rates are going, but explicitly go out and run explain analyze to see if going out and grabbing that data out of JSON is slowing you down. Okay, that was the conclusion. I mentioned that I was doing this ass backwards. So now for the introduction. Traditional relational databases are designed for sets of data. The idea was reducing data duplication on disks because disks were very slow and very expensive. Structured query language is the only the only language from the 1970s that's still around. COBOL was the 60s, Fortran was the 50s. I won't go into things like Alloc and all that. Now, the reason it's stuck around is it's very powerful, very flexible. Yeah, it's quirky, and the syntax is kind of messy. But It's really a handy tool and it's very powerful. Now, the various vendors have their own implementations of some of the things that's standard and that make things vary. But it's kind of a universal axiom that SQL is SQL. Now, the great thing about traditional relational databases is they love stability. Going out and changing the data structure is a real mess. If you've never had to do a big table change or something like MySQL, where basically you want to change a 10 gigabyte or 10 terabyte file, suddenly it has to have two of those files out there and starts moving things slowly between the two. That is a real pain in the butt for performance. Now, one of the interesting things is before you can use a relational database, you have to go out there and define the data structures. You have to create tables. If there's any interactions between the tables, like foreign keys, you have to set that up. And this area is where a lot of stumble. It can be difficult. Now, JSON script object notation is now the data interchange format of choice for developers. Those of you who remember back in the days where your choices were ASCII or EBCDIC will kind of grimace. Some of us are probably old enough to remember having to do everything in XML. It's kind of messy. Now, something great about JSON is it's flexible. There's no rigor imposed, which is also one of its problems. Also, there's no way to put in by default required fields or values. Now, it is easy to read and compare to something like XML. Really easy to parse, and that's why JSON has become the data interchange format of choice for developers. Now, document databases building on JSON were designed for ease of use. You have a document out there and you want to add a new key value, you can put it in there. You don't have to go out to the underlying schema and add a column and data type and all that. You just plug it in. The query languages are kind of implementation dependent. If you've played with Mongo or MySQL's document data language, they're a little bit different. You're actually sending arguments back and forth in JSON itself. It gets kind of messy. But the great thing is you can embrace the chaos. Once again, if you're in an environment where things are changing rapidly, there's no constraints on you. If you need to put it in there, you can. Now, trying to do things like perform traditional relational database things like adding indexes and all that, depending on whose NoSQL database you're running, that could get tricky. But the great thing is there's no prerequisites. You don't have to go out and set up a schema and then add tables and before you can add things. You just basically open up the collection and start writing to it. Now, once again, the JSON data type stores an exact copy of the input text. And in this example, we have a table cutely called NoB, and we're going to insert into that NoB a key, an ID of 1. We're going to have foo with a value of bar. Whoops. X is 1 and X is 2. And if you select that from the JSON data column, you notice that we have foo bar and we have our first X with a value of 1, second X has a value of 2. It went in, the JSON document went in exactly the way we put it in there. This item potency is very important in some cases. Odd bad joke for me is my first book that I wrote, I was talking about item potency, which means it's identical going in as it comes out. And one of the editors somehow turned it to impotency, and it wasn't caught in time before publication. Okay, so let's create a table called YesB, which is JSONB. And we're going to insert the same data, foo and bar, x1 and x2. But when we select from that JSONB column, x:2 is the only one that shows up. x1 has been dropped. This is part of the optimizations that JSONB has. So once again, item potency, if you need it to come out the way it went in, that's the way you want to do that. You do that with JSONB, you're going to get disappointed. Selecting data, if you do a select data from YesB, here we have 2 rows, you're going to get a JSON document. Now, if we go out there and use the arrow operator, we're going to get the value. We're looking for the data for the key of X and whatever values come back. So we have our values of 2 and true. Now, I highly recommend that if you're new to JSON, go out there to the Postgres manual, read through the JSON functions. There are a lot of them out of there. You'll probably end up using only a handful of them at first. And there's a lot of really cool stuff up there that I really couldn't mention. Uh, there are limits on this talk, but I highly recommend that if you're new to JSON, this is what you should be reading in your spare time for the next week or two. Now, with that, I'd like to thank you. Please do me a favor and go out to dbeaver.com and take a look at our database management tool. It lets you do all sorts of wonderful things. Over 140 databases are supported, might be 150 by now. If you're dealing with a lot of different databases at one time, this is really the way to go.